Yeah.
Yes, students. Uh, turn on the camera, Shranshi. Yeah. एक बार पिन कर दो.
Hello.
Hello, yes, ma'am.
Yeah, Priyanshi, can you give me the introduction?
Okay, ma'am. I'm Priyanshi. Currently, I'm pursuing my BTech from Indira Gandhi Delhi Technical University for Women. I'm also in, I'm also undergoing my training at VLSI from all for RTL and design verification. Under that course, I have designed and stimulated various designs such as UART, SPI protocol, I2C, uh, I2C, SPI. I have also designed asynchronous and synchronous FIFO. Yes,
Okay. Yeah, you have the system Verilog and UVM, right?
yes, ma'am.
Okay, fine. Um, so you know about the mod port and clocking clock in system Verilog?
Yes, ma'am.
Can
So
you like explain me that?
in clocking, block is used to stimulate our clock, and mod pods are basically used for data communication within our code.
Okay. So what are the main use of them?
A clocking block is specially designed for our clocks where we generate our clock. We provide the time period for the clock, and later we can use that clocking block wherever we require them. And mod pods are used for data transfer within our code. For example, I want to access a data from another function or from another class.
Okay. So you know about the shallow and deep copy,
Yes, ma'am.
or what are the main use of them, and what is the
Okay.
difference between them?
Ma'am, shallow copy and deep copy are the are the process wherein we can access the properties of another class. We use shallow copy basically means that we just take the properties from another class and we can assign our own values. Whereas in deep copy, I'm a bit confused within.
Okay, fine. In the shallow copy is used to copy the class properties like integers, strings, intents, handle, etc. And nested objects are not copied. Only
Okay.
the instance handles are copied, which means any
Yes.
changes are done in the nested copied object will also reflect in the nested or original object.
Okay.
Okay. But in the deep copy is same as shallow copy, but except the nested created objects,
Okay.
they also like get copied by the by writing a custom method.
Mm. So basically in deep copy, if we copy properties into another class and if we make changes over there, the same changes won't reflect to the base class in deep copy.
Yeah, in deep copy, it is almost same as shallow copy, but except the nested created objects, like
Okay.
they also get copied. Yeah,
Okay.
yeah, yeah. You know about the mailbox and queue?
Ma'am, actually I haven't revised that part. I thought you
Oh.
would be asking questions from project, so I
I
know I should have known that, but actually I'm
yeah,
having a
yeah.
lot going on that way.
Okay, okay. So you know how to write the assertion.
Yes, ma'am.
Suppose you have a 4-bit counter.
Okay.
Can you write it in a copy?
Yes,
I'm
ma'am.
like telling you that if you have a 4-bit counter CNT,
C and T. Yeah.
no CNT,
Okay. Okay.
which increments on every positive edge of a clock,
Okay.
when enable is higher. You have to write an assertion to check that the counter never exceeds 15. Have you understood the question?
Yes, ma'am.
Okay.
Ma'am,
Yes.
ma'am, can you confirm this much if I'm going right?
You have used the assert. You haven't used the assert.
Yes, ma'am, we will assert the property.
You have not used it.
Yeah, right now I've not used it.
So using the assert property, you can like easily do this like add, assert property in brackets. You can write at the rate. At the rate means there's some delay with the passage clock disable if and only if uh, in the brackets not enabled.
Yes, ma'am.
Then CND less than equal to 4 bit D15, and else it will give the error.
No, I was confused at how I'll access the pausage of the clock in assert. Like I can write
Now,
this code in entire in I can write this entire code in one line. Yes.
in assert property in brackets you can write at the rate passage clock.
Okay.
After that you can write disable if and only if brackets in brackets not disabled.
Okay. I was familiar with disable if, but I haven't used it.
Okay. Yeah, after that outside this block you can write here disable space and now write the if and only if. No, double F.
Okay.
Yeah, in brackets you have to write the not enable. Not operator.
Mm.
Yeah. And here you can write the condition of CNT. It
Okay.
should be less than equal to
For I is equal to 0. I have to go like this only, no? The condition will be written like this.
you can also write normally that CNT less than equal to,
Okay.
or if it it equal to 4D15, if CNT equal to 4D15, else it will give the error counter exceeded 15. Yeah, after that you can write the else part. You know about the how to write the constraints.
Yes,
Okay.
they are written within curly braces.
Yes. So you have to write a rand constraint on a 3-bit variable
Okay.
with distribution 60% for 0 and
Okay.
to 5 sorry with distribution 60% for 0 to 5
Okay.
and 40% for 6 and 7. Have you understood the question?
Yeah, I'm a special operator. We use a special operator for this kind of stuff. I don't remember that, but I'll try.
Okay, okay. Yeah, I will help you. If you know how to write the cover point, you can also write it after that. You know how to write the cover point?
Mm.
Okay, okay, fine.
And is it right like this?
You have declared the class. Okay. Then now
And I know that for percentage, for stuff like this, we use a special operator. There's a special symbol. I can't recall it right now.
okay. Yeah, it's almost correct. Um, we can like use this also. Up to you.
Okay.
It's almost correct. So can you write a constraint which is divisible by 5?
Yes, ma'am. A modulo 5 should be equal to 0.
Yes, yes, yes. Equal to. You know about what is the difference between the double equal to and triple equal to?
Yes, ma'am. Double equal
What
to
is the
checks.
difference?
Double equal to checks for the logic inequality and triple equal to checks for the case inequality. Like in case of double equal to, it will treat uh, like in for triple equal to, it will treat x triple equal to x, it will treat it as a true value. But double equal checks for the
Okay.
logic
It
inequality.
means that it will have the more inputs, like we can give and compare the x and z values also.
Yes, ma'am.
Okay. So you know about the difference between the new square bracket and new round brackets.
Yes, ma'am. Basically, new round bracket is known as the class constructor. When we initialize a class and we want to access it, we specify the name of that class. New round bracket is equal to specify the name of that class, and whereas new square bracket is basically used in arrays to initialize our arrays. Uh, yes, ma'am.
Okay, fine, fine. So have you have done FIFO, right? So in FIFO, what is the difference between the synchronous and asynchronous FIFO?
Ma'am, in synchronous FIFO, the read and write operator share the same clock, whereas in asynchronous, the read and write operator have different clocking domains. Synchronous FIFO is bit simpler and less complex. Asynchronous is a bit complex. We can use asynchronous FIFO if we want to establish communication between a fast speed peripheral to a low speed peripheral.
Okay, okay. So you know about the difference between the synchronous and asynchronous reset.
Yes, ma'am.
Can you show
Synchron.
me like writing in that what is the difference between them?
Okay.
So why this is synchronous reset?
Ma'am, because it is using a clocking edge.
Okay, you can like change in it all only. in this always block to show the asynchronous.
Ma'am, for asynchronous reset is basically independent of the clock-in signal. So,
So what will the statement inside the always block?
ma'am, it will be asterisk. Like it will depend on the clock and reset both.
Yes, yes. Or you use or between them, passage clock or passage reset.
Yes, ma'am.
Yes. So if the width of the FIFO is 3, if the width
Okay.
of the FIFO is 3, then what will be the depth of it?
8.
Yeah, 8. And what will be the how many bits will be of the right pointer and read pointer?
3.
Um, are you sure?
Ma'am, basically width means the number of bits we have in each entry. So like the data which we
No,
will
the
provide.
width means the address, the address width of a FIFO.
So ma'am, this width doesn't mean the data which we will provide to the FIFO, the width, the bit number of bits which would be there in each set of data entry. That would be 3.
The address, the pointer address, it would be
Okay.
3, so it can make it to 2 to the power 3 is equal to 8 there. But the data inside the FIFO is not linked to it. It will be 8. Okay. So I'm sharing my screen. You have to calculate the. Are you able to see the screen?
Ma'am, not yet.
Okay.
Yeah, ma'am, now it's visible.
Okay. Okay. So FA frequency A is greater than the frequency B with no ideal cycles in both write and read. So writing frequency is equal to FA. Okay. It is 8 megahertz and reading frequency is 50 megahertz. And burst length is equal to the number of data items to be transferred, which is 120. So there are no ideal cycles in both reading and writing, which means that all the items in the burst will be written and read in consecutive cycles. So this is the like question.
Okay, ma'am.
What will be the depth of the FIFO?
Can I use the calculator?
Yes, yes, you can.
Yes. Ma'am, is it 2 byte?
Hello.
Yes, ma'am.
Yes, what you have said? What was the
Is
depth of the FIFO?
ma'am, I'm getting 2 bytes.
No.
Ma'am, wait, let me try like this.
Okay, okay.
I'm getting 2 bytes right now.
Okay. So how you have calculated?
Ma'am, first I've calculated the time for writing, like 1 upon 80, and for reading 1 upon 50. Then I've multiplied them by 120. Then uh,
No.
Yes, ma'am. Ma'am, I
Calculated
have.
the time first of all.
Yes, ma'am. Yes.
You got 1 upon 80 megahertz.
Yes, for that I got 0.0125 nanosecond, and for reading I got 0.02
For
nanosecond.
writing, you should get the 12.5 nanosecond, I think.
Right. Ma'am, then the units might have, I have to change the unit. Like if we divide the megahertz, then we'll get the answer in nanoseconds.
Yes, yes, yes. And for reading you will get I think 1.15 megahertz is equal to 20 nanoseconds.
Okay, I'll get the answer in. Like, ma'am, if I'll divide 1 upon 80 megahertz, the time I'll get in nanoseconds. So that I'm getting as 0.01 to 1 upon 80.
01.
0.0125, 1 upon 80.
Yeah, it you're mistaken in some like nano things, but you have calculated it right.
Okay,
12.5 nanosecond will be answer for the time to write one data item.
okay.
Nanosecond is 10 to the power minus 9, right?
Yes,
So
ma'am.
you should like add the more 10 below. We need more 10 below, I think.
Ma'am, is it 107?
No. After that, what have you done? Like after the time and after the read and write time?
Oh, I have multiplied each by 120. Then I've divided the reading time. I'll get 1500 divided
No,
by
you will
120.
only multiply the
Okay,
right
so
one.
for that I'm getting 1500.
Yes, below you should write the 20 nanosecond only.
Okay,
You have understood why?
no, ma'am. Okay, ma'am, to see that for reading, how much time we will, for how much time we will need to read
Yes,
these
yes.
many
So for
bits.
every 20 nanosecond, the module B is going to read one data in the
Mm.
burst.
Okay, ma'am. I got 75.
Yes. The remaining number of bytes we have to calculate. So we can like subtract the 120 by minus 75.
75,
Yes.
45.
Yes, fine. That this is the correct answer. Your approach was like correct, but you have mistaken some calculation, I think.
Okay.
So now, can you calculate this question?
Yes, ma'am. Ma'am, here while calculating the time, I'll divide, like for A, I'll do 2 upon 30, na? Like,
Yes,
because
yes,
I'm having
yes.
two, so, okay.
Yes. Why you have divided by 2? Means 2 by 30?
Ma'am, because it is mentioned that number of idle cycles between two successive write is equal to 1.
Yes, yes. Okay.
Ma'am, once can you confirm the timing for A? Is it 66 nanosecond or something?
Yes, yes. 66 point something.
And for B, it is 4 nanoseconds.
For what?
4 nanosecond.
For the read one?
Yes, ma'am.
No, no.
I'm getting 0.04. So,
No, that's not correct. Please continue with I'm coming in 2 minutes, okay?
okay.
Yeah, Priyanshi, have you done?
No, ma'am.
So,
Ma'am, I'm getting.
related to the VLSI, have any companies came to your college?
Ma'am, only NXP till now.
NXP, okay. So you have given that interview.
Yes, ma'am.
How was your interview? You selected?
Uh, no, ma'am. Ma'am, it was more for a embedded profile.
Okay, okay, fine.
Yes,
So
ma'am.
like, so they
Ma'am, they
asked
were,
embedded question.
yes, ma'am, mostly from C. Like
Okay,
my interviewer, she was, I don't think she was having any knowledge of Verilog. Like she
oh,
was asking more of analog stuff from me.
okay, okay. Maybe that. So the JD was of the embedded part.
Yes, ma'am.
Okay,
Ma'am,
fine.
it was for digital as well, but I think they came for embedded only because from none of us they asked Verilog or digital questions. They were focusing more on
Okay,
C
okay,
and analog stuff.
okay. So have anybody selected from your college?
Yes, ma'am. They took three students, one from MTech, VLSI, and two other from BTech.
Okay, okay,
But they didn't came from FT for FT, like they were offering 6 month intern only.
okay. Is there any package or something?
Yes, ma'am. Stipend was around 45, and they mentioned that they will give PPO based on performance.
Okay, fine.
Ma'am, I'm getting minus 80 for this one. I went ahead with a time for B as 40 nanosecond and for A as 66 nanoseconds.
What the read time?
40 nanosecond.
No, it will not be 40. In the question.
Ma'am, I'm a bit confused with because when I'm dividing 20 by 50, I'm getting 0.04. So I thought it might be 40 nanosecond.
No, your read time should be 40 divided by 50 megahertz. 4
Okay.
divided by 50 megahertz.
Then it is 80 nanosecond.
Yes, yes, 80 nanosecond.
Okay, ma'am.
Because the number of idle cycles between the two successive write is one clock cycle, and the ideal cycles between two successive read is three clock cycles. It means after one reading the one data, module B is waiting for the 3 clock cycles to initiate the next read. So it can be understood that for every 4 clock cycles, one data is read.
Okay, ma'am. Now it is 20.
Yeah, 20 is fine. In UART, what you have made? What is the purpose of the UART?
Ma'am, UART is basically used for a serial data transmission. There are two transmission lines in UART, TX and RX. also for UART, we don't require any clocking pulse for synchronization. That is why it is also known as asynchronous.
Okay.
Like the major purpose of UART is that if we want to send our data serially. So I had like I have to describe the entire project.
Yeah, yeah.
Okay, ma'am. So the frame of the UART is basically the start bit, then our data, then our parity bit, then the stop bit. So in my module, in the entire project, I had following modules, which were first it was the clock generation, then the baud rate generation. In baud rate generation, I basically divided my clock into small pulses.
So
Then
wait, in the baud rate, you said, so what is the difference between the bit rate and baud rate, you know?
yes, ma'am. Basically, they are uh, like bit rate is basically the number of bits transmitted per second, and baud rate. Ma'am, I think they both are same.
No, they are not same
Ma'am,
actually.
baud rate might be uh, bits transmitted, like number of bits transmitted and number of bytes transmitted.
Actually, baud rate measures how many times the signal on the line changes state in
Okay,
1 second.
okay,
Like there is a bit difference between the as it is like we can say the transitions for the baud rate, and for the bit rate it is the number of bits.
okay. So, ma'am, if I want to explain it, I'll say that bit rate is basically the number of bits transmitted per second, and for baud rate, it is the number of times our signal is
Times
toggling.
yes, yes, the signal on the line changes in 1 second.
Okay,
Yes.
okay. Should I explain further?
Yes, yes.
Okay, then I also have parity bit generator and parity bit detector. So in UART, we also have a facility wherein we can check the errors using parity bit. There are two kinds of parity bit, even and odd. In parity bit generator, we basically XOR the our incoming data. Like we XOR each bits of our incoming data, and the final output which we get is our parity bit. And in parity detector part, we basically compare that parity bit. We basically compare, okay, we basically XOR the data again, and the output we get, we compare it with the received parity bit. And if they are same, then there is no error. If they are not same, then there is a error in the data. So, uh, in UART, basically, there are fixed baud rates which are supported by UART. So for clock generation,
So Pranshi, like in the chat box I have given you something, is it like correct to write? Is it possible?
yes, ma'am, like if we do within brackets, A within brackets, so it will XOR 1 and 0, then 0 and
So
1, then
what we say this operator?
XOR.
Yeah, but there are only one operand, right? So what will we say that?
Like we are XORing each bits of the data.
Yeah, but we don't have two operands, right?
Yeah. So self-exoring, vector,
No,
self.
unary.
Okay. Urine. Yeah.
Yeah.
Urine. Okay.
Yes. Yeah. You can continue.
Uh,
You were in the parity, right?
Yeah, no, ma'am, I was on the board rate. I was basically explaining that how I generated the clock.
Yes.
Like, uh, ma'am, can I use something to
Yes. Yes.
explain?
Your screen is now sharing, so you can like share it once you complete it.
Oh, like in UR, the supported rates are so if we want to generate, let's suppose, let if we want to generate a clock for 9600 baud rate, then we will take TP as uh, 1 divided by which would be 104. So for clocking period, we will take it as TP divided by 2. For this amount of time, we will toggle our clock.
Okay.
Um, then in a baud rate generation, we can also use select lines to decide which baud rate we wanna go ahead with. For example, I'll take 0, 0. Like there are two select lines, S1 and S0. We can take 0 and 0 for 4800 baud rate, 0, 1 for
So what is
9600
the use
baud.
of this?
Ma'am, we can provide the values of S1 and S2, and it will basically uh, go ahead with that baud rate. Like if I provide the 0, 0, it will go ahead with this baud rate, 4800.
So can we have the fractional baud rates?
Fractional, like apart from these values.
Yes, fractional. I mean the fractional baud rates.
Yes, ma'am, we can have.
Okay, like it's correct. We can have the your fractional baud rates.
Ma'am, basically, ma'am, since UART is universal, so there are fixed baud rates which are supported by the UART, but we can use.
Yes, yes, that's correct. We can have the fractional baud rates. So you are so how we can choose the baud rate for communication?
Ma'am, for that we can have a combinational conditional statement like for 1, 0. Um,
Okay. So you know about the art, UART and US art.
it's for synchronous, but I haven't heard about it. US art.
Yes, the normal UART is asynchronous. It means no clock, only TXRX. But
Okay.
US art can be synchronous or asynchronous, which use the clock in synchronous mode.
Okay, ma'am. So here we
So,
don't require a baud rate for synchronization.
mm, so why we have the stop and start bits?
Again, it's for the receiver side to know that the transmission has been started. Like if there are two devices and one device is uh, the second device won't know when the transmission is being started. So for that purpose, we send first bit as a start bit. When it is low, like when it is zero, the the other device gets to know that the transmission has begun, and for the stop bit, when it is one, then the other device gets to know that it's the transmission has been stopped.
Yes. So, how many data bits can you transmit at a time?
uh, One for stop bit, then seven for data, one, two for parity, maybe one for stop, 12 or 11.
Usually 8 bits, I think.
Okay. I took 8 bit of data. Like the data is of 8 bit, then additional bits for start,
Yes.
stop, and parity.
Okay, okay, fine. So, what do you mean by the SPI?
So SPI is serial peripheral interference. Uh, it uses or four select lines for the transmission. Uh, it has master and slave. When that for the select line for the data transmission from master to slave is known as MOSI, and for data transmission from slave to master is known as MISO.
Okay, so what is the role of the chip select
Um,
in SPI?
Chip select basically tells us that the master wants to communicate with which slave.
Okay, so where you have like learned these protocols?
From training at VLSI for all.
Okay, okay. You have purchased all the project part, SPI
Yes, ma'am.
before
Yes,
you
ma'am.
are. Okay, fine. So how the data is transferred in the SPI?
Ma'am, basically, we have MOSI and MISO. The the LS bit or the LSB of MOSI goes at the LSB of MOSI goes at the MSB of the MISO, and here the LSB of MISO goes to the next clock cycle towards the MSB of the MOSI. Like
Okay.
serially, the data is being transmitted bit by bit.
Okay, so what is the role of the polarity and phase in SPI? You know?
I think polarity basically means the MSB and LSB of the data.
No, it determines whether the clock signal is high or low when it
Okay.
is ideal. Um,
Ma'am, you asked polarity and one more thing. What was that?
phase.
Is I haven't heard of these. I look
Okay,
into
so
it.
yes, yes. So phase determines whether the data is sampled on the rising edge or the falling edge of the clock signal. And by changing the polarity and phase, we can have the different modes of SPI communication. Okay, you know about the full duplex communication?
Yes, ma'am. Basically, full duplex is like with transmitter and receiver, when we can send and receive the data between the two devices simultaneously, is known as full duplex.
Okay, so can SPI communication be used for full duplex?
Yes, SPI is full duplex.
Okay. So can the SPI communication can be built in a multi-master environment?
Multi-master. We can have multiple slaves, but no, we cannot have multiple master. For SPI, we can have multiple slaves.
There can be a scenario where we can have the multiple master.
Like, ma'am, for I2C protocol, we can have multiple master and multiple slave.
Yes. With the careful coordination between the master devices, we can have the multi-master environment.
Yes, ma'am. For SPI, can we have multi-master?
Um, what you are asking?
For SPI, can we have multi-master?
Um, for SPI, we can have the multi-master. Actually, the SPI is this which normally has the one master and one or more slaves, right?
Yes, yes.
So we can have the multiple master, but it's not common and it will be more complex. But we can have it.
Okay.
Hello.
Yes, ma'am.
Yeah. So in I2C,
Okay.
what you have made?
Ma'am, I used the I2C protocol. Basically, I designed a master which can be our any processor or CPU, and two slaves which were temperature sensor and LED display. So the master first send the slave address and register address to the temperature sensor. The temperature sensor sends the data as in a, like, for example, 55 degrees Celsius to the master. Then master again sends the slave address and register address, and in return the LCD display sends acknowledgement to the master, and like that uh, the display receives the data from the master and displays it on the screen. So here I have one master and two slaves which are communicating using I2C protocol.
So in a scenario where with the multiple I2C devices on a bus, how do you address the potential address conflicts?
Okay. Like, ma'am, we have our acknowledgement signal. If there, uh, like, ma'am, you're asking in terms of timing.
Like how you will plan the address potential.
Okay, ma'am. So, first we'll have our starting condition,
Yes.
which will be sent by the master to the slave. The slave will receive that starting condition. Then the master will send the address of the slave with which it wants to access, and the slave will receive that slave address, and if it's valid, it will send the acknowledgement as 1. If it's this address is invalid, it will send acknowledgement as 0. Let's suppose that it was the valid address, then next the master will receive the acknowledgement, and it will send the register address which is inside the slave. For that also the slave will send the acknowledgement or not. Then once the master has received the acknowledgement that the slave register address is valid, it will send the read or write signal, whether it wants to read the data from the slave or write into the slave. For example, let's take our example. First, we are reading the data from the temperature sensor. So it will send a read signal. The slave will capture that read signal and it will give out the data which is stored in that register to the master. Then after the transmission is complete, the master will send the stop condition, which is basically done is equal to 1. The slave will capture that. Then after that data has been stored within
There
the
will be acknowledgement and there will be acknowledgement, right?
yes, ma'am.
So please mention that also.
Like, ma'am, acknowledgement would be for the slave address and slave register address.
What what is the ACK and NACK? I'm
It's
asking
for
about.
the acknowledgement, and NACK is for invalid. Like that.
Yeah, yeah. That's what I'm asking you to mention. Yeah.
Okay, okay. Then once our master is having the data, it will again send the request to the LCD display, which is the slave. The slave will capture it again. If the address is invalid, the master will say send NACK. If it's valid, the slave address is valid, then it will send a acknowledgement signal. Then same, it goes like that. It will send the register's address. If it's valid, then it will go ahead. If it's not valid, it will send the invalid signal to the master.
Okay, so
Last
why the pull-up register are required in I2C?
pull up register. Um, I don't have any idea about this right now.
Okay, so suppose we have the two masters start at the same time. What
Okay.
will happen?
They are accessing the same slave.
Yeah, there will be the corruption of data or like some.
Like, ma'am, in I2C, the master and slaves are connected with two transmission line, which are SDA and SCL. So SDA is
Okay.
basically bidirectional. So, and also it is local to its slave and the slave and the master.
Okay.
So, also, ma'am, earlier which I mentioned, the data transmission, uh, the SDA is the only line wherein the data will be transmitted. So if for perspective, SDA, if SDA is 0, then data is being sent from master to slave, and if SDA is not 0, then the data is not being sent from master. The data is being received from the slave side, and same for the slave's perspective. So as you said that how the uh,
What
two
will happen that if two masters start at the
yeah,
same time? Yes.
ma'am, there will be a collision. Like if they are accessing the same slave, there will be a collision if they are starting at the same time. Like slave will get signals from the slave will get starting condition from two masters. Yeah, I
Okay,
think it is
what
like
do you think?
uh, I think slave can answer them both. Like after the start condition,
Yeah, it will depend which will first
yes, ma'am.
win, but the data will not be corrupted.
Okay.
So one will and one will, and we will get the output. Yes.
Oh, and I think if the both master sends the request to the slave at the same time, they won't get a acknowledgement from the slave.
But one will win, so we will get, and we will not have the corrupted data.
Like one master will get the acknowledgement and other won't get any.
Yes, one will win.
Okay, okay.
Any of the one. Yes. So, how does the I2C ensure the synchronization?
Ma'am, there are various signals which are used in I2C for synchronization. For example, there is a starting condition, then there is a data direction which we mention in a code, like for uh, like if it's 0 for master's perspective, then master would be sending the data to the slave, else it would be receiving the data from the slave. And for slave's perspective, if the SDA is the condition for the if the data direction is 0, a slave would be sending the data to the master. If it's not, then the slave would be receiving the data from the master. Also, there is a stop condition which is driven by the master and received by the slave. So like that, the synchronization is done. Also, there is a clocking, a serial clock in between them. So yes, the main synchronization is done by the clocking signal, SCL signal.
So, where you have used the I2C?
Oh, I have used I2C to get the temperature from
Okay,
the temperature sensor and display it on the LCD display.
okay, fine. How you get interested in VLSI?
Sorry, ma'am.
How you get interested in VLSI?
Okay, ma'am. So uh, basically, I saw it on LinkedIn that there are lots of opportunities in this field, and there is a growing industry in India, and also Indian government has invested a lot in semiconductor industry. Also, there are many companies from outside investing on Indian land. So the basic interest started from there
But in
only.
your college, I think you will only get the software
Yes,
companies more rather
yes,
than
ma'am.
the score. So, like, how you why you decided to?
Okay, ma'am. The first reason was that I always wanted to do something around my branch only. I
Okay,
knew that the opportunities would be less. That is also one of the reason I purchased this course.
okay.
Yeah, the major reason was that I don't want to go into tech. I want to do something around my field only, my
So
branch.
you got interested in VLSI, like you feel
Uh,
happy like to do this or
like, ma'am,
something?
I wasn't very confident while doing TSA and stuff.
Yeah, okay.
Also, yes, also we had a subject wherein we were introduced a little bit with VHDL. So like that, I got interested in towards that. Then I saw basic videos on YouTube like AND gate, NOT gate, designing uh, simple logic gates. That's how I got more interested. I thought I could do this better.
Okay, okay. So why you decided to be the design verification engineer and not
Um,
PD or design engineer something?
Ma'am, the a major reason was that the job opportunities in this domain is bit
Okay,
high, the number of jobs. Uh, Also, in my coursework, I got introduced with VHDL. Then I opted for FPGA and verification subject where I got introduced to Verilog. So I thought that this might work for me. Like
okay,
also, I don't think I have a very good incline towards analog stuff, like back end stuff.
okay. Fine. Uh, uh, a bit technology also and the coding part also. Yes.
Yes, ma'am.
Okay, fine. I think that's all for today.
Mm.
Do you do you have any questions for me?
Yes, ma'am. Again, I would like to have a feedback on my performance.
Yeah, I think you were good. You have the good concepts around it, and you can like brush up more the SV part, and we will see in the next interview.
Okay, ma'am, for next
The SV and
interview,
UVM.
yeah, for
Yeah.
UV.
Yes. Yes.
Okay, ma'am, like next
We will.
interview I'll be having towards end of the October because right now I'm having my mid-sem. So for at end of the October I'll be giving next interview.
Okay, fine. We
Okay.
will be focusing on the UVM.
Okay. Ma'am, also there are in this course there are other projects like router and all. Should I do that also? Or as a because I'm a fresher, should I?
Yeah.
Okay, ma'am.
Yeah, for folk for more knowledge, and because your concepts are a bit cleared, I think. So you
Okay.
can do that also for knowledge,
Okay,
for
ma'am.
more knowledge. Yeah. Okay.
Thank you, ma'am.
Any other questions?
No, thank you, ma'am.
Okay.
Okay.
Thank
Okay, ma'am. Can I leave?